So I'm going to show you how water hydrogen bonds with itself and how that gives it some of its water properties. So I'm going to start with one of these magnetic water molecules. You can see that they're magnetic so that you can show the hydrogen bonds. So here's a partially positive hydrogen, partially negative oxygen, so that would be a hydrogen bond. There's another hydrogen bond here. And then the lone pairs are here on the oxygen, so they're going to hydrogen bond with two more waters. So the center water is surrounded by 4 water molecules. Okay? And so you can have a whole bunch of these water molecules all kind of stuck together when water is in the solid state. Now, what's not accurate about this model is that all of these would actually be one hydrogen bond distant from each other, not right up against each other. So if you can imagine them kind of all off, like out into space 1 inch from each other, because they are all being held apart, one hydrogen bond distance from each other, they're actually less dense than when they start to move around and they can bang into each other and get a little closer. So this would be more like liquid water, and then vapor would be far apart. So that'd be gas. So the hydrogen bonds, when they're in solid state, are keeping the water molecules just a little bit apart from each other, and they're in sort of a lattice formation. Okay, so now I'm going to show you how water is a great solvent. So here we have a giant chunk of salt. The chlorides are the green spheres and the sodiums are the blue spheres. And when salt dissolves, what actually happens is the water molecules start to surround the salt and start to break it apart into ions. So since this is chlorine, the hydrogens hang out around it, and they just sort of surround it and pull it away from the other other sodium and chloride atoms, right? So now it's surrounded, the chlorine is surrounded, and you can see the chlorine is surrounded by the hydrogens because the chlorine is negatively charged. And so when you have salt water, the sodium and the chloride are all completely surrounded by the water, and that's why you can't see it anymore, because it's all suspended in the water. You can see salt when it's all together, right, because it's all one big chunk. But when salt dissolves, it's all surrounded by the water. And so that's why water makes such a great solvent, because it can surround charged things and partially charged things. Water is not a good solvent of hydrocarbons. So this is ethane. It's just carbon, which is the gray, and hydrogen, which is the white. And there's no, this model doesn't have any magnets in it. There's no interaction between the ethane and the water, so they don't surround because there's no interest here. There's no attraction. So this is just going to be hydrophobic. It's going to stay away from anything that's charged or polar. Okay, so again, water is going to surround anything that's charged or partially charged, and that's why water is a good solvent. And water is less dense as a solid than as a liquid, because every hydrogen bond that can form in a solid forms, and the hydrogen bonds are actually spaced apart. They're not actually connected, they're spaced apart. So when you have all the hydrogen bonds formed, every water molecule is one hydrogen bond distant from every other water molecule. And it isn't until you add energy or heat energy that they can collide and come closer together, because you're breaking the hydrogen bonds. And then when you have so much energy, you're going to spread them apart like in a gas.